inputs to change those things work. So when you are integrating them to your code, you know how to have that control in your code. So when you add the Rive animation, you will now be the one to control it with your code. So that's what creative technologies do. They work with the designers and the engineers and work out that animation logic. So even you as a developer, you should know about Rive, you should know about this, so you can even advise your designer properly. Okay, use this logic instead. Use this instead because that's what will work in the application. Do you get? If you got me, can I see your hand? Okay. So let me just... I talked about Rive runtimes. Rive runtimes is what drives the code, drives the animation in your code. So this is where, after they've done all the magic in the editor, in the Rive runtime is where the whole control happens. So, and Rive has different runtimes for different frameworks. You have a Flutter runtime that Rive has already made available, and that is what we use to control the animation. Now, Rive gives you that, for Rive's animations are very high performance and very small. The files are very small. We have they are below 100 KB. You see 10 KB, 12 KB, so how small the files are. So you're not thinking that this is going to make your app heavy or whatever. They're very highly optimized. So when you build your animation in Rive, you control it in your Flutter code. So Rive is bringing control to developers. There's more you can do in animation now, not just the normal pick and drop. You can actually now control the animation states in your code. So I'm going to take you through these different features that you can use in your Rive runtime. So the Rive editor is where the design happens. The Rive runtime is where you can integrate it in your code, right? So let's move on. Okay, we have 3 different features I want us to discuss right now that are available on your Rive runtime. We have events, we have textures, we have dynamic assets, and state machines. Now, for events are what you can use. First of all, events are designed at, they are put into place at design time. So while the animation is being designed in the Rive editor, that's where we add events. So if, let's say, the aim of that animation is that maybe at when so and so happens, maybe when this particular animation state comes up, you can put an event there that something should happen in your code. Do you get? Are we together? So what happens with events is that if, let's say, with that animation you are creating, you want this to happen when, let's say the animation can have 5 different states. You want at the 3rd state, show some code, or open a URL, or change the color of the background. You want something to happen. You can add that event during design time, and then listen to that event at runtime. Do we get? Are we together? If you're together, say yes. Okay. So you create those events at design time and listen to them at runtime. I'm going to show you a sample of that. Now, the animation I want to show you right now was created by JCToon. All these animations that they are on the Rive community. If you go to the Rive website, you see the community where people can just come and post what they've worked on and share with others. And even those animations that are being posted, you can go there and edit, take a copy of it and reinvent it however you want that will suit your use case. So in this case, I took one. So I'm trying to let you know that it's not me. I'm not the one that has this animation. I didn't build it before you think so. I just got it, and I added event to it, and I'm showing you today. So this is the real animator. So what's happening? This, at the point where this robot jumps up, I'm telling the code that show something, show a text, right? So I added an event to this particular animation that comes up at the point where it's at that jumping state. So at that point where you jump, I'm telling my code, listen to it. When it jumps, show, welcome to FlutterBytes Conference, right? So just think about it for a second. What are the possibilities? What do you think this can do for you as a developer? What do you think you can do with this? What are the extra things you can do in your application? You know, people are used to apps these days. Apps seem to have some same kind of format. So whenever someone sees something new, the person gets engaged. So there are new things that are possible. The reason why we are sharing these things are for you to know them and build on top of them. Because all we have been doing are things that we have been building on the works of other people. So when you see, okay, this is possible, then you think of another thing that is possible for you, right? I want to show you how it is in code. So we have a callback we are listening to on Rive events callback, where we are catching this event here and saying, okay, if the event.name is equal jump, print got event. And it's in this function that I'm showing that text. Do you get? We have the place where this is the function that holds the Rive animation. Now, there are different ways you can load an animation in your Flutter app. You can have it as, you can do Rive animation.asset, you can do Rive animation.file, you can even do Rive animation.network, where you host the Rive file wherever you want to host it, and then you can load it in your application. So when we use Rive animation.file are the instances where maybe you are using the animation at different points in your code, and you don't want to have to reload it at different times. Just load it once, and then just call the instance. Do you get? So let me explain this better too. At this point, we have the state machines. Now, I want to give a disclaimer. Don't try to grasp everything at once. Get the concept, because there are different other details in it that you may need to go and study. But the point is, when you created events at design time, you can listen to them in your code, right? So I'm going to explain the point of, this is where we added the event listener. This is the callback. You remember the callback that we defined earlier? This is where we put it. So the controller is listening to that event, and then it's making the changes to the Rive asset that we have, right? Okay, so I'm trying to be fast so that I show you everything before the time is up. Next up is text runs. Now, for text runs, Rive gives you the opportunity to create animated text. So not only animated characters or animated UI, you can also animate your text. You can create a text and animate it in Rive and then have it in your application. But the extra thing now is that for those animated text, you can make it, you can put it in what they call text runs. And text runs means, like maybe for a line of text like this, I can divide it into two parts, and each word is a run. And what does a run do? For a particular run, you can change the animation style, you can change the color. So you can have a sentence like this, but a different animation here, a different animation here. Do you get? So that's in the Rive editor, and then you can control it in your Rive, in your Flutter code. Now, control, what I mean by control is that you can read and update the text in your code. If, let's say, on the editor you have the text as username, in your code you can put the real username, the real person's name in your code. Do you get? Okay. So, like I was saying, we can read and update animated text at runtime. I'm going to show you a sample. Wow. Okay, wherever we stop, I'll just share my slides, okay? So the text sample I'm going to show you is from someone that built it as well, Pedro Alfera. I didn't build it, but I added stuff to it. And this is the sample. So we have a text field where I added my name and I passed it to the animation. Do you get? So when I created this animation in the Rive editor, it wasn't Nikki that was there. You can see the Nikki that is showing is the one that I typed in, which means any name that is typed in this text field is what we show here. Right? Okay, so this is where I created the function, or rather, created the Rive animation.asset that I passed these different parameters into the state machine, the assets part, and all of that. But this is the fun part. This is where I got the text run. Now, for this text, you have to name, the name you give it in editor is what you use to locate it in your file, right? So you do addboard.text run, and I named it name. So this is what I'm going to use to locate it in my code, right? Okay. Okay, so we get this, right? So let me just go ahead. This is where I passed, now this is where I passed that name I entered. This is where I passed it into. So text run.text. Now for dynamic assets, this is another thing that Rive gives you the opportunity to do. With Rive, you can actually replace your asset dynamically at runtime. And if, let's say, for an animation, you put some assets in the animation, and you want to load it differently. Let's say you want to load it as an embedded asset, which means it comes with a Rive file binary, or as a reference asset, which means you want to add the asset yourself. You want to load it yourself in your code. You may put it in your asset file or whatever. We have the hosted, you can choose to host the asset outside and then load it, while you are putting in the asset in the Rive animation asset in your code. There are different ways. But the beauty about this now is because it lets you load assets by yourself, you can also replace the assets in state machines. State machines, you can combine different animation states and manage the transition between them through series of inputs that can be controlled from your code. So state machines have different inputs that you can use to control the different animation states. You can put events in state machines, you can do a lot, you can put listeners. Now, I may not be able to explain all these different words I'm saying, but there are things you can easily go read up on the Rive documentation. So we have a sample of a state machine where we have an animation that has different states that we controlled with inputs. So this is a sample by Guidoroso, and I edited it a little bit. So this is how the Rive editor looks like. Let me explain it quickly. This is inputs. We can see we have two inputs. We have a number input and a Boolean input. These are the different animation states that we have, aside from the state machine. We have a state machine graph where we can add the different animation states. In these arrows, you can pass the inputs that will handle the transition. Because before you move from one point to the other, from one animation state to the other, you can add a condition and say, okay, only move from here if downloading is true. Only move from here if progress is 100. Stuff like that. That's where the animation logic comes in. So, this is how the animation looks like. You click on it. One question, am I very fast? Do I speak very fast? Okay, I'm glad that you're getting me. Okay, this is how it looks like. Now, this is what you have in your code, and it is timed for 60 seconds. So it's moving like that. When it gets to 100, it goes to the finished state, right? So what I just did behind the scene briefly is I defined the seconds I was using, defined the timer, defined the state machine controller. These are the two inputs that we have on our design, the editor, downloading and progress. Then in this function, okay, is my time up now? Okay, I can round up. All right, I wouldn't, but you can go through the code later. Now to find all of this code, if you're on that link that you opened up, you can go to my GitHub. It's among my pinned repo, Rive/Flutter, you find it there. So let me not explain all of this. So you can build animations in Rive and ship them with Flutter. And I have a package that I built, which it's really not, a lot of things happening, just animated icons that were built in Rive that you can access with your Flutter code. You can go check it out on pub.dev, but really you can use any of these animations in your Flutter code as you wish. You can customize the color, the size, the stroke width. It has all of that. Just go check it out. So I hope you enjoyed this session today, and you can check out my GitHub or...
Thank you, Nikki. Keep clapping, keep clapping. Thank you so much. That was really nice. Guys, if you enjoyed the session, please tweet about it. Our handle is FlutterBytes Conference, so CONF at FlutterBytes Conference. And on Instagram is FlutterBytes_C. Please tweet about it and use the hashtags. Thank you very much. Okay, so we're going to the next breakout session. Thank you so much.
Thank you.
So over here, we have... sorry, give me a second. Okay, so in this hall, we're going to be having designing offline. First Flutter apps for performance and reliability. Designing offline. First Flutter apps for performance and reliability. Then we also have building a watch party with Flutter. That is at Nairobi. Building a watch party with Flutter is at Nairobi. And then we also have securing Flutter apps, how I can hack yours and how you can stop me. That's going to be at Cape Town. Did we get everything? Do you want me to run over it again? Okay. So, at Nairobi, building a watch party with Flutter. Okay. So while I'm mentioning it, we're going to take a good picture with Nikki, please. So the photographer will describe it, but just listen for the next one. So at Nairobi, the main hall, we have building a watch party with Flutter, right? At Cape Town, we have securing Flutter apps, how I can hack yours, and how you can stop me. So if you're interested in that, Cape Town. And over here, there's designing offline, first Flutter apps for performance and reliability. So did we get that? Okay, so let's take a picture with Nikki, please. And then you need to go immediately. Please, everybody, come in the picture. Thank you very much. Come on, there's space up. Come on up. Nikki, we can't see you. Thank you. Okay, yeah. Okay, everybody wants... If you are short, they won't see you, but okay. Hi.
1, 2.
Will they see you? Yeah. They'll see you, don't worry. They can't see you.
We can get evidence of it.
Okay. Right. FlutterBytes Conference. FBC 2024. Okay. 3, 2, 1, go. FBC 2024. Okay, fine. 3, 2, 1, go. FBC 2024. Thank you, guys. Please, we need to go to the next breakout session immediately. I'm going to read it once more. Building a watch party app with Flutter. Oh, okay. Sorry. I'm so sorry. So I'm going to mention the speakers' names as well. Building a watch party app with Flutter, Ijeoma and Deborah. Securing Flutter apps, how I can hack yours and how you can stop me, Rexford. Designing offline, first Flutter apps with for performance and reliability, Christopher and Nelson. Accordingly, the first one is Nairobi, the second one is Cape Town. Nairobi is the main hall, second one is right on top of this, Cape Town, and then there's one here. So if you're... Okay. Where's what?
That's Nairobi all. All right, so what is happening here? What is happening here is designing offline first Flutter apps for performance and reliability. Designing offline first Flutter apps for performance and reliability. And that will be handled by Christopher Nwonsu Madreke and Nelson Eze. I'm going to say that again. Designing offline first Flutter apps for performance and reliability. Designing offline first Flutter apps for performance and reliability, and that will be handled by Christopher Nwosumadweke and Nelson Eze. Thank you very much.
Thank you. Offline,
Sure.
first, Flutter apps for performance. Ready, guys? Yeah, you can use it. You can use the mic when I'm done. There's another mic.
Hello. All right. This is cool. All right. Yeah. Yeah. Okay. Okay. Why are you giving us this ones? Why are you giving us? All right.
All right, guys, so we're about to get started, and this particular session is designing offline first Flutter apps for performance and reliability. Our speakers are Christopher Nwosumadweke, a mobile engineer who is passionate about creating innovative apps that solve real-world problems. He's a natural storyteller who loves simplifying complex concepts so that they are easy to understand while delivering exceptional user experience. Our second speaker is Nelson Eze, and is a senior Flutter developer at Nouveau. Am I pronouncing that correctly? Is a software engineer with a passion for building innovative software and turning ideas into impactful products. His experience spans across multiple industries where he has worked on diverse projects that push the boundary of technology and creativity. He has also led the team at Nesturge, an e-commerce platform for digital creators. Please let's welcome our speakers, Nelson and Christopher. Guys.
All right. Hello everyone. Is it loud enough? Is this loud enough? All right. All right. So first off, I think I need to make a simpler introduction. All right.
Yeah.
My name is Christopher Wonsumadueke. I'm a mobile developer. I use mainly Flutter. I am an organizer for Flutter Akure. And generally, I'm happy to be here with you. And this is my co-speaker.
Okay, so well, like you said, I'm Nelson, just also a Flutter developer. So yeah, let's keep it short.
You don't want to correct them on the Nestuge.
Okay, well, I'm also the CEO of Nestuge. It's a monetization tool for digital creators. So if you sell digital products, courses, online classes, you can use Nestuge for that. Yeah.
All right. So today we'll be talking about designing offline first apps, and the main aim for it is performance reliability. All right. We all know the story that happened with was it when MTN went down? Nobody was able to. Or sorry, when the networks went down, nobody was able to do anything. Some people couldn't even open their apps. Right. Some apps could open, some couldn't open. You know how that went, right? Right. So this particular session aims at addressing that. Right.
Yeah, all right. So this is just a summary of what we're going to look at today. The first one, we're going to define what an offline first Flutter app is and data flow structure. We're going to talk about the sync engine, sync modes, multi-device sync system. So as you see, we're going to talk about sync a lot because it's the major part of this. And then we share some light on performance and best practices. So yeah.
All right. So first off, what is the offline first approach? All right. I have a couple of slides set out for this, and I'm just going to be running through them. Okay. What's happening?
Okay.
It's offline.
Offline, yeah.
All right. All right. I'm happy you all got that.
We need to switch to the offline mode now.
All right. Now we're going to offline mode now. All right. So we're back. Offline first in general, right, is basically creating applications that do not rely heavily on internet, which means generally when internet is off, you're still able to do the activities you can do, right? It leverages generally local storage, has some important techniques that are involved in which we are going to be going through on this session, but the main part of it is you recognize your local storage as your source of truth. Right, so everything that the user sees, that the user does, first of all, has to have the local storage in it. All right. Now we have the flow chart or a miniature flow chart here, showing how data flow works in a regular application. All right. Now, when you have internet connection, from your mobile app, you can trigger something. You can decide to make an action. You can decide to fetch data. It interact with the remote server. Remote server are things like AWS, Vercel, your cloud, your backend, etc. Right? And it responds to the client. It brings the data back to the client. Now, without internet on a regular app, it can't make that interaction. Right? So it tries to reach the remote server, but fails. Right? So now that's the issue we're trying to address.
Okay, so now this is another flow where we've modified something, and as you can see, we've added the local server and we've added the sync engine. So what this does is that instead of making the request directly to remote server, we create a local server, right? That, for example, creates a transaction. We're going to explain what that means, in a short time. It creates a transaction and sends it to the sync engine. So the sync engine is now what is responsible for the data fetching, caching, and the storage. And it communicates directly now with the remote server, right? So the sync engine, like I said, let's take, for example, your social media app, right? Twitter, for example. And have you guys ever seen a time that you open Twitter and you don't see any feed? You don't see anything on your feed? No. That's because it actually leverages the offline approach. So the first time you open your app, right, it makes a request to the server, and it fetches data and store in the local database. And the subsequent times you're going to make requests, you will now have to get this data from the local database. And the sync engine is responsible for managing this whole thing. So it stores the request in form of transaction, like I said, in a transaction queue. So for example, you like a post or you repost, it would still show you that that was successful. It won't tell you that you don't have internet, right? So it creates a transaction as the like or the comment. And when you have internet, it now syncs that change to the local, to the remote server. So basically that's what the sync engine does. And the local data storage, so like I said, we have to save the data somewhere, right? So even if you upload an image, for example, or you add a comment, so a comment is a data, we need to store it somewhere, right? So we do this through local database, like for example, we have Hive, SQL, we have shared preferences, and we also have Objectbox, right? So this is where you can store this data. And when the client requests for data, you retrieve the data directly from the local storage, right? And the catching in the sense that when we make requests to the remote server, we don't want to always do this every time, right? So we have to catch the response and make the request periodically. Let's say 10 seconds or 1 hour, depends on how you want your application to perform. So yeah.
All right. So now that we've stored the data on the local storage, right, we have to get that data that's in the local storage back to the remote server, right? Now that's the essence of syncing the data synchronization. You're making what is on the local server and the remote server consistent, right? Now, there's some steps that are involved in it. You need to first of all know when there's an internet connection. So you need to have this constantly being checked, right? And then when you have a good internet connection, you then want to sync this. How does this happen? You can either do a push, a pull, or both, right? What does that mean? You have data on your local, right, that you want on your remote server. What do? You push. Right, you have data on your remote server that you want on your local server, right? You pull. Now there are cases where you have data both on your remote server and on your local server that you want synchronized, right? So what happens? You have to first of all do the both of them, right? Now the next slide is going to talk about how to basically go about that. Now you can go about it. You can encounter errors. You can encounter conflicts when this happens, right? And that's the last part, conflict resolution, right? Now, say, let's give you an example, right? Someone comes to me and tells me, go to the door. Another person comes to me and says, stand there. That's a conflict, right? So what do we do? Right, so or how do we resolve it in this case? Now that's what this is about. We can do the last right wins. The last person that wrote to me or that said something to me said, stand still. I will decide to stand still. All right. We can do manual intervention. What that means is, he has told me, go to the door. Someone has told me, stand still. He's the person that gets to now decide, do I want to go to the door? Do I want to stand still? Right. The user gets to make that decision. You provide the user with the two use cases, go to the door, stand still, but he gets to make the decision of what happens. And then there's the third part, either merging or patching it, right? And what does that mean? Someone has told me, go to the door again, and another person has told me to stand still. I can decide then to go to the door and then come back and stand still, or go to the door and stand still there. Right, what does that mean? I have put the two commands together and done the two requests.
So there are many approaches you can take to build your own local server or your own sync engine in this case. And we don't want to tell you do it this way or do it that way. We will just tell you what a good sync system should have. And one is that it should be secure. So we're dealing with local network here, right? And there are security concerns, so you have to implement ways to secure this. It can be having an ID that the device has to provide. Another way is you have to, like as Christopher explained, you have to manage conflicts, and he also has to monitor the network connectivity. So, like, you understand that when a user opens the app the first time, they don't have internet, right? And we fetch the data from the local server. So you have to know that, okay, the internet is back on, and we need to get the fresh data. So that's what monitoring network connectivity means. And it also has to enable two-way data sharing. It means the client should be able to send data through the flow back to the remote server, and the remote server has to also send data through the flow back to the client also.
All right, so let's talk about sync modes. Where do we make this sync? Why should we make this sync? Where we make the sync? All right. Now, you open, is it Instagram, I think, right? And you see some new feeds or some new, what's it called? What? Thank you. Some new reels that are already stored, right? And sometimes you can do this with your internet off and still see that something has been updated, right? You open the app and you automatically see some things there, even if your internet is off. Now, what happens? Did this sync happen when you opened your app? Did it happen before you opened your app? That's what this is about. All right. Now, foreground, right? Generally, when your app is open, it's in focus, it's active. You are seeing the UI of your application. The sync can occur then, right? So you're just generally making calls, like you said, every interval, 1 second, 10 seconds, 1 hour, depending on how frequent you want it to be. Or it can happen in the background. Now what that means, your app is not in focus, it's not active. In some cases, it's not even open, all right? Now what that would do is, basically the ways to go about that is either using push notifications or work manager. I'll give 2 instances. Now I have an app. It's not called Instagram. It's called, what? Instagram. Yeah, that's very lame, but let's use that, right? I want to update the data on my app, all right? I can decide from my end to send a push notification, all right? And when a push notification comes in, it has a particular lifetime that it can do a certain set of operations, all right? Now, you can do whatever you want to do within that timeline, all right? You can hear the case of 30 seconds. It should not be open for too long. So whatever you have to do, your sync, your pull, your push, whatever should happen within 30 seconds. There's also the case of work manager. So for those who don't know about work manager, it's like, call it a task scheduler. All right, so hey, you do this thing every 10 minutes, do this thing every 1 hour. That's what it does. All right, you give it the task to update, to do this whole sync every interval. That's what the work manager way is.
Okay, so let's explore, or let's take this a little bit further, right? So we've done where you have one device and it has a local server, it has a client, and it has a remote server. So what we want to do now is we want to have one device that acts as the main device, and other devices can connect to this main device. And that's what we call multi-device sync system. So yeah, exactly. So this is the first, and I don't know if anyone understands what I mean by client. The client, you have the front end, you have the back end, right? So that's what I mean by client here. So the client sends, the first device has both the client and the server, and other devices are connecting to the local server of this device. And then we go from the local server to the data engine. The data engine is where we store the data, and then back to the remote server. So I'll give a more concrete example. Next slide. So let's take, for example, a multiplayer game, right? So you have these games that you can play. It will tell you to connect to my device, and then let's play together. But I am the main player, so I can be the player 1, and then you are the player 2. So what actually happens here is the player 1 has a local server. The player 2 also has a local server, data engine, and all of that. But if I'm initiating the game, then you have to connect to my local server. So basically what you're doing is that you're sending a HTTP request to my server, right? If it's pull, push, get, and all of that. So we're not connecting to a cloud or a remote server somewhere. It doesn't even have to use an internet, right? And so we can play this together. So if I have any change, maybe if it's a football game, I move the ball, I send you a push request saying the ball has been moved, right? So you get the update on your second, that's this player 2, right? So, but maybe you wouldn't understand this. Or can you think of an example? I have given a multiplayer game. Can anyone tell me an example of an app that has this sort of architecture? Exactly. Chess.
I like that.
Good. But there's a popular app that we all probably, maybe not all use.
Not necessarily a game.
Okay. Exactly.
Thank
Zenda. So this is how Zenda works, right? Zenda just creates, once we connect to the same local network, so the device that is the main creates a local server, and the other device connects to it. So the push, if I'm sharing a file, is just a push HTTP request. Yeah. So that's it, and these are other examples, and we'll quickly rush through the best practices.
All right. Before we get chased off the stage, right, let's just give you one or two tips that you would definitely need to know. All right. Now, there's 4 ways to make this thing better. All right. Lazy loading data, setting the time to leave, data compression, data encryption. The last two, compression and encryption, seem quite explanatory, right? Now, there's lazy loading data. What does that mean? You load a particular set of data only when you need it. You don't just query your entire database and bring out everything to show to the user, right? You need to see the user's, maybe his game score, query that. You need to see what level the user is on, query that itself. It makes your app smoother, makes it faster, and makes it efficient. In terms of time to leave, you have a particular set of data that you are storing. You don't want this data to be on your mobile, on the client's device forever, or until the app is actually uninstalled. It's going to do one thing. It's going to increase the database, increase the storage size, the storage used by the mobile app. Right? You don't want that to happen. So what do? You set the time to leave. That's sort of like an expiry date for the data. When that date reaches, it cuts off, it's removed, it's deleted. All right, so we have benefits of the offline first app. I'm guessing with what we've said so far, I can be able to tell 1 or 2 things about it. All right, but then the first I'll mention is faster loading times. Basically, you're able to load without having the network latency. All right, you don't depend solely on internet connection. And then accessibility. You don't have to be in a place with internet connection to actually view maybe the most previous data that you've had. Imagine WhatsApp. You open WhatsApp now, you're in Zambisa Forest, let's say, right? And it shows you, oh, I can't load your chats. And let's say you have the data you want to get from maybe your helper's phone number, but it can't show you that because you're not connected to the internet. That's going to be a problem. Now we're having also...
Yeah, the reliability, well, always reliable, right? And then it increases the overall performance issues, performance increase, because you don't have to always make a request to your server and all of that. So basically,
all right.
Yeah.
Thank you, everybody. Before we do go, can I take 1 minute to ask, are there any questions? All right, question. First thing, if I said ask your question and he said don't ask your question, which would you go with?
Conflict resolution.
Okay, cool. Let's say your question.
My question is based on the architecture that you gave.
All right.
I don't know if I'm the one that's confusing you, but you said local server.
Okay.
So I'm wondering, how do you spin up a local server with Flutter? Do you like a local server, or
Okay.
is it maybe running background process?
Okay. Local server, local storage. In this case, every operation what's a server? Basically, a server helps you do like something like, sort of like a set of operations, right? It can also be connected to like a database. Do you understand? Right, so let's use that example for it. A local server, you're able to do all the operations you still want to do, and you're having a local database to support it. And the local database in this case is, like we mentioned earlier, your Hive, your SQL, shared preference, etc. So that in this case is what we call the local, what we grouped as the local server.
Yeah, just to add to that, you can actually spin up the local server with local host inside Flutter. Yeah,
Mm-hmm.
you can do that. But we don't have time to take questions, so we can have that after.
So come meet us. We'll be at the back. All right. Thank you very much for having us. These are our handles. You can connect with us on here.
Pictures now with the speakers. Please wait.
Oh.
We're going to take pictures, but I'll also be announcing the next session that is happening here as we take the photos. Hi, everyone. Thank you. In this hall, we have AR on maps with Kennedy J. Ken DJ, sorry about that. AR on maps with Ken DJ. So if you're looking to join that session, please, you can stay back here. And then in Cape Town, we have bringing blockchain and Web3 to Flutter. Bringing blockchain and Web3 to Flutter. And then in Nairobi, we have Flutter Fever catching the text bug. I'll say it again after we have the photos. Are we ready? You can climb up. Can we move quickly, guys? We're out of time. Are you good? Okay. Okay, so we're going to do a video, and say FBC 24. 24, yes. FBC, FlutterBytes Conference 24. So 3, 2, 1, go. FBC 24. Okay, now with more drama and like energy. 3, 2, 1, go. FBC 24. Thank you very much. Okay, so running to the next sessions. We have AR on maps with Ken DJ here. We have Flutter Fever catching the test bug with Oluwaseyi Ajadi and Jesse Osile at Nairobi, right? And then we have bringing blockchain and Web3 into Flutter by, this name is a little hard to pronounce, but that is at Cape Town. If you're for AR on maps, Ken DJ, you are in the right place. If you are not, then you're in the wrong place.
as it helps in visual representation of a technology that you wish to view. For instance, do you guys have elephants here? No? So if I want to bring the elephant in the room, it's very easy to do that. That was a very nice pun. Okay, English is hard. Anyway, if I wanted to bring the elephant in the room, then augmented reality would be an easier thing to do that, because again, we are displaying content that we want to visually see, but isn't really there. You get it? No? Yes? All right, we'll get it along the way. Okay, but what about maps? So according to Google, maps is a that word, representation representation of an area of land or sea showing physical features like cities, big buildings, etc, etc, right? Okay, cool. So, a quick question. Is augmented reality and maps really a good combination? Is it, now that we know what AR is and what maps is, are they really a good combination? Are they a perfect combination? Perfect combi? All right, let's see. Well, they are, because they enhance each other's capabilities to create more immersive and informative experience for users. But how do they do that? In what field? What examples do they do that? Well, number one, they help in real-time turns. For instance, if you're using your maps and you want to see which direction you're going, so then it helps, it brings like the turns that you are moving. If you're moving right, then it shows you you're moving right. If you're moving left, then it shows you're moving left. And then there is another example of indoor navigation. So we have malls here, big malls, right? That have different shops with different thingies, but then maybe sometimes you wouldn't know where an exact shop would be. Then maps, augmented reality would be like a very good thing to like exactly show you where you're going and display the turns that we've just talked about, as well as displaying the names of that particular shop that you want to go to. And then it helps in obstacle avoidance. Are we all blind? No? Yes? Okay. But then sometimes you could be on your phone a lot, right? Let's say you're checking your maps and you're just walking, but then you wouldn't know what obstacle, maybe it's a roadblock or a car coming, or such examples. So then it would be a really nice example to help you in obstacle avoidance. And then we have the virtual tours. Let's say, for instance, you want to know how Nairobi looks like. Yes? You want to like visit Nairobi virtually. And then, so if we have an example of maps and augmented reality with a whole representation of how Nairobi looks like, then you could take a whole tour in Nairobi while you're in Lagos. How cool is that? It's amazing, is it? And then we have historical and culture context. So, quick story time. Okay, this is a perfect time for story. So, I realized here in Lagos, you guys have an amazing place that displays the culture of the Yoruba people, and it actually displays it in an augmented reality view. I don't know if you guys have gone to visit your national theater yet. Technical challenges? Okay. It happens in real life. How do I do that? Sorry guys, we are learning on the job. We are yeah, we are debugging in real life. Yeah. Oh, so we are basically how do I share? Share on your email. How is it that you're saying I share this one?
Yeah, so we can just present from there.
So you can enter into
Okay, wait.
I hope that works. Yeah, debugging in production at work. Yeah, it was deployed on Friday. Wow. You should open a comedy session. It's okay now. Caesar. Okay. Sorry guys about that. And then we have the interactive experience. So on the interactive experience bit is how many of you have ever worn those VR? How does it usually feel? It always feels like you're in that particular view. All right. Now back to the elephant that I was telling you about, the elephant in the room, yeah? You would feel like you're actually interacting with an animal in a field that isn't in their nature to be, right? So that's what I mean by interactive experience. Alrighty, so let me show you a visual representation of the AR using maps. It was playing while I was making these slides, I promise you. All right, cool. So here we have an example of somebody who is trying to navigate through a street, and you're able to see now the augmented reality bit, which shows you where they are, the location, as well as it shows you the arrows that we were talking about that shows you which direction to take, and also displays the map bit at the lower bottom place. Okay. Moving on, we have the augmented reality and culture. So, on this particular view, do you guys know a Gugun Lord. Yes. So this was me playing around with, interacting with this particular Lord here, Lordship, and you can see this is a visual representation of augmented reality. Like you're able to make moves, and at the particular time, whatever moves that you're making, it's displaying on that particular view, yeah? And that's another easier way of augmented reality. Oh, and by the way, this is the culture place I was telling you about here in Lagos. All right. Moving on, we have an indoor navigation using the augmented reality. So this can happen in places like malls, airports, when you're lost and you're trying to find your gate. So it's able to like display to you properly where you need to go according to your destination, okay? Okay, internet. Alrighty, so let's move on real quick and then maybe try to like understand what exactly is this augmented reality. And here we have AR Core and AR Kit. So in this example, I'm going to show you an application that I built using AR Kit. So AR Kit is a package for iOS bit, for iOS engineers. However, AR Core is an example is a package for the Android bit. Okay, so this was an example of an application that's running inside a bed, and the laptop is, don't worry about the setup, it doesn't matter. But what matters is you're able to view a view literally floating inside a room that basically is in the native place of the particular animals that are showing. That's the great migration that happens, okay? Okay, so moving on. We have another package here that is the AR Flutter plugin. And this is a really nice package because it runs on both Android and iOS. So if you're debugging with your Android device, then you don't have to use AR Core. AR Core, yes. And if you're using your iOS device, then you don't have to use the AR Kit. However, you can just use the Flutter and AR plugin, which basically runs both the devices. But then here's something that you need to take note of. This particular package hasn't been updated for the last 2 years. So as mobile engineers, as really smart people in the room, it would be a really nice thing for you to play around and try to like update the package, or even create your very own package and be constantly updating it, okay? All right, cool. Now let me tell you more, even if I only have 5 minutes. So if we want to set up the augmented reality, then we need to like set up at least the UI, the UI first. And this is basically how you set up the Maps UI. And you see we have very simple thing. It's a very simple application that has the body as the Google map. And then these are things that you need to first of all enable. You need to enable the location and the markers, and the markers basically is where you set the particular marker ID, and then you set the particular position. And by position, I mean the longitude and the latitude. So if you come from the equator like me, you can just set 0.0, 0.0. But if you come from, I don't know the location for Lagos, you can set it up to there, okay? Alrighty, so let's go to the fun part. The platform channel. So anybody who knows why we're using platform channels? Yes? No? No? Very few people. Okay, amazing. So we are basically using platform channels because we are using Flutter. Flutter is a cross-platform framework. You don't write native, but it compiles natively. However, you don't write native, yeah? But then the reason why we're using this is because we have a few things that we need to access natively, which is the camera. And you cannot access the camera just like that without bridging to the native. So that's why we're using the platform channel. And when it comes to the platform channel, we have a very amazing method here, which we've given the name to Open Camera. So you need to take very good note on the Open Camera name, because we'll be using this, but we'll be referencing it on both the Swift code and the Kotlin bit. All right, so this is an example of a code base on Kotlin bit. And you can see AR camera, no? Okay, the Open Camera name that I was telling you we need to reference, because then we need to call that method on the Kotlin side so that we are able to actually access it. All right, let's go to the native side of the iOS bit. Ooh, iOS people are very extra because this is a lot of code. This is incredibly a lot. But as you can also see, we have to reference the name somewhere in the code base. Open Camera, the method. This is where you're referencing it. Okay? Cool. Yeah, that is me anytime I always try to bridge to the native because it's a lot. But let's continue. So now that we've set the native sides properly, so we need to set now the overlays, or rather the coordinates of how we're going to where do we want this particular AR view to be on your screen. So we have to set the coordinates according to the screens that we have. And sometimes this can be a challenge because of the different screen sizes that we are probably using, and also the fact that I don't think this is a very much explored topic. So sometimes we get lost on it, and sometimes we just guess the coordinates on it. However, this is a very simpler way of setting the coordinates. And also here on the shape, we have a sphere. However, when you're using the AR packages, you're able to change to different sizes, either cube, sphere, circle, depending on what you want. Whew, that was a lot. Okay. So, are there any permissions needed? Yes, we need a couple of permissions. So, when it comes to the Android bit and the iOS bit, we need a couple of permissions. For example, internet is a must because we need to we are accessing data in real time, and then we also need permission to access the location, and permission to access the camera, and the permission to access the hardware on the Android bit. So are there any technical challenges? Well, few or a couple. So number one is the user device capability. This comes to how good your device is and how well it can accommodate this particular technology. And then we have the real-time data processing. Sometimes we might be having issues with internet and such stuff, so that could be a technical challenge. And then the accurate location, where are you exactly, so that you're able to access this. All right. Are there any future prospects? Absolutely, and I think there are very many future prospects, and in very different fields. Number one, we have the advanced computer vision technology, and then we can also play around with the integration with other emerging technologies like the 5G, the Internet of Things, in planes, in other technologies. There's so many prospects where you can use augmented reality, and even in storytelling, actually. Okay. Now I am done. This is your favorite part. Are there any questions? Mm-hmm. A visual display on the AR? On maps. Okay, so here's something that I didn't tell you guys. I had an issue with my API on my Maps API, so I wasn't able to like. It's not able to display properly. It's basically displaying a blank screen at the moment, so that's why I opted to just showing the code base. Yes. Sorry? Yeah, absolutely, yes. It's open source.
Is it? Okay. So where can they find it?
On my GitHub, I will share.
Okay.
Yeah.
Amazing. Thank you so much. Really enjoyed Okay, I hear the applause. Okay, so before we go to the next session, does anybody want to quickly give a summary of what they learned? Anybody? Are you sure you guys don't want to give a summary? Not a single person. Okay, hi. Mm. All right. Well, you know, if you build the cat, you get the gift of the cat, Abby. Come outside. Come. Thank you so much. Thank you so much. Okay, so we're running into the next session, but we're going to take a photo with Kendi. So can everybody please come on stage? She's gonna stay in the middle. Everybody's gonna take a photo with her. So like, it's a group photo. Guys, please let's make it quick. Thank you. We're about to go into the next session.
It's okay. I got it. Thank you.
What is the photographer? Please, can you come arrange us? Oh, thank you. If you're taller, you know the drill, go behind. If you're closer to the earth, come forward. You know the drill, My bro, you're going to cover the people even standing. Okay, now. Kendi. Where is she? Okay. Guys, can some people move here? It looks a little clustered on that side. Can some people move to this side, please? Let's go. Time is going. Thank you, guys. Okay. If you can't see the photographer, he can't see you. Thank you. Wow. Okay, so while he's still arranging us, the next session in this hall is going to be FFI the right way, delivering messages with Pidgin. FFI the right way, delivering messages with Pidgin. And it's, okay. Sorry. Okay, so video, and we're going to say FBC 24. Come guys. FBC 24 at the same time. 3, 2, 1, go. FBC 24. Okay, do you get it? Okay, thank you guys. Thank you. All right. I'm sure the other sessions have probably started, so you guys need to get there as soon as possible. If you're going for state restoration, making the dead state live again by Samuel Abada, that is at Nairobi. If you're going for decoding that, an in-depth look at that VDM, that is at Cape Town, directly. And if you're going for FFI the right way, delivering messages with Pidgin, that is here. I'm going to take it again. Please listen. If you're going for state restoration, making the dead state live again with Samuel Abada, that is at Nairobi, main hall. If you're going for decoding that an in-depth look at that VDM that is at Cape Town, directly above us, and it's Festus Olusegun. If you are going for FFI the right way, delivering messages with Pigeon, that is by Sebastian Ode. That is here. I'm very sure that we got that. That's VM, sorry. VM. Sorry. I was reading. The topic of the first one is state restoration, making the dead state live again. Making the dead state live again. Okay, so this is the guys for this place. FFI the right way, delivering messages with Pigeon. A pigeon.
That is what the session is for. Huh? Okay. Wait for the session.
Okay. I'm guessing the other halls are not done yet, so more people are not here yet. Wait a bit, or let me go back. Are you ready? Okay. Your mic is ready.
Most of us have some experience with Flutter, right? Okay.
If you're for FFI the right way with Sebastian, then you're in the right hall. Okay. Please, as you're coming in, just move forward. Thank you. FFI the right way. Yes, please. Anything behind the third row, please don't sit on it. Thank you. Yes. Are you for FFI the right way? Okay. Please don't sit anything after the third row. Anything after the third row, please don't sit there. Thank you. Anything after the third row, please don't sit there. Thank you very much. That's how, Okay, okay. I was about to shout. Okay. Look at that way. That way. Okay. Are we waiting for anybody else? If you're for FFI the right way, please don't sit behind the third row. 1 to 3 is free. Enjoy yourself. Okay. Well, we can't keep waiting, so we're going to get started. Yes, I think we can get started. All right. So I'm going to introduce Sebastian. Media, are we ready? Media, are we ready? Sorry, guys. Okay, so this hall has FFI the right way, delivering messages with Pidgin, and it's going to be delivered by Sebastian Ode, senior mobile engineer. He is a mobile engineer with 4+ years of professional experience building Flutter apps at the edge, that is working with native platforms. He's very vast in building awesome experiences and looking into the Flutter internals, if required, to bring proposed features to life. As his Twitter profile says, he is a modern blacksmith who is currently at Flutter Forge, and he crafts widgety molds and weaponry applications. You'll find him wherever a screen exists. Okay, please welcome Sebastian Ode, senior mobile engineer. Guys, thank you.
Good afternoon, everyone. Good afternoon. So I'm here to help us talk about a problem we're dealing with native platforms with Flutter, and we're also going to discuss a solution. We're also going to discuss a solution. So we are Flutter devs here, right? Most of us. Has anyone had to work with the native platform? Can I see a show of hands? Have you had to work with the native platform? All right. What approach did you make use of? Meta channels, right? What did you make use of? The native platforms from Flutter. Yeah, and how do you do that? Via meta channels, right? Definitely. So there are problems with meta channels right now. And what are some of the problems you had when you tried this interaction?
Because I started writing Kotlin before I listened to Flutter.
Yeah.
So, Kotlin has been something like, when talking about the Android language, most times you can just say Kotlin. So, when Flutter came in, because, Flutter developers now are not like, okay, you don't need to spend twice, so they're for Flutter. And then we're trying to get into the Android, let me say, in-depth of Android functions.
Yeah.
So there are some things that even on the pub.dev to be asked to find packages.
And plugins for.
Tweaking your Android manifest, all these things can cause a one-time problem for you that feel like
Yeah.
So, there are a lot of challenges trying to get into it due to let me say there are no tutorials for that online.
Very few resources, yeah.
So you'll have to come up with this thing yourself, try to tweak even some packages that you see on pub.dev, you'll have to tweak the package yourself to meet the real this thing.
Yeah,
The major problem is resources.
Yeah, that is one thing I am here to help you solve, to make tweaking those packages easier for you and more sane. But before we get to that, that is what we are talking about here, FFI the right way, delivering messages with Pigeon. Yeah, short info about me. I think of myself as a software thinker, like she mentioned for my Twitter bio. And I currently have a team with Flutter and mobile. I've been in the mobile space for 4+ years now, and I've been building Flutter apps for most of that. I also enjoy coding and running simulations. So I like games that are sort of simulating something, a hacking experience. Recently, I am playing games that simulate Git, and I also enjoy coding the simulations myself. So think of simulating physics. I do that on the side. And currently, I'm trying to leave a mark in the fintech ecosystem in Nigeria. I work at Aku Fintech, Aku Africa, where we are trying to revolutionize mobile, the fintech space. We're trying to build apps that affect and leave a mark on the people at the base of the pyramid. That is your mothers, your fathers, trying to build intuitive experiences for them. So that is what we do there. And that is a little about me. And let's get to the conversation today. So what is FFI? That is the topic, right? FFI is foreign function interfaces. And they are means by which a particular language can converse with another language without necessarily learning about the language. Like the tagline says, bridging language barriers one routine at a time. So communication between these languages and these dynamically linked libraries are usually referred to as routines, and that is what FFI is. And in Flutter, because you want to communicate with your host platform, Android, iOS, Windows, Mac, Flutter is multi-platform, they are all running their own separate environments, right? Flutter is its own unique environment, and we want to communicate with them. Flutter has method channels, which is what everyone is familiar with. Method channels are used to communicate to the native platform, but there are a lot of problems with method channels, which we'll highlight some of the problems here. So, in your standard Flutter application, you have the Flutter environment communicate within host platforms via method channels. Just little implementations, we'll go over that. Communicate to the Android host, iOS host, for example, and via meta channels, which I've said before there are a lot of problems with. And for our workshop today, we are going to refactor this. On the left-hand side, this is the code required to call an addition method from the native platform. So I want to add 2 numbers. You can easily do this on the Dart end, but I'm trying to get us to understand how to do this. So we call the method channel, we invoke a method called add, and we pass an input 1 and input 2 in a map. And we also have a method channel variable here, FFI the right way add channel. This is something. And on the native platforms, this is the main activity for Kotlin. And we have to pass the name exactly as we pass them here and the add method. And then we also have to call the arguments and pass them. We do similar on the Swift end. We call the dictionary, we have to first cast. And that is one of the problems with dealing with using standard method channels. You have to typecast, you have to cast. And there's also the problem with the namings. If anyone is familiar with method channels, you could easily mess up the namings. There are strings after all, right? You could mistakenly write a C instead of a D here, and that would break everything. So Pigeon is a solution that removes the need to write all this code here. With Pigeon, you don't need to write as much, and you don't have to face the issue with typecasting. A plugin I used at my company some few months back had problems communicating with the native Swift side because they asked you to pass some configuration options. And when you pass said configuration option, it breaks. Apparently what the package was doing, it was trying to convert a string to a hex, but it was casting it wrongly, so it broke the plugin, and plugin was on the pub.dev. You don't want to ship bad plugins, do you? So we are going to go with the type-safe approach that the Flutter team had created for this reason. And talking about types, you can see there is an entire chart where you have to check the respective type for each of the primitives. You can see null, there's null type, int. You have to specify the type of int you are dealing with. This is very cumbersome, and this is a lot of points of failure, and Pigeon Help removes that. Yeah, I am here now, the force is with you, and we are definitely going to make that code better. So, introducing Pigeon. Yeah, like I mentioned before, Pigeon is a code generation tool that generates all the code requires to communicate from Flutter to the native end. So with Pigeon, you can work with a double on the Flutter end and work with an exact double without doing the conversion that we did before, having to extract the input, then casting. With Pigeon, you don't have to do that, and I will show us how. So when I use Pigeon, this is all the code I need to perform my addition now. I don't need the method channel. I don't need to know about that. I just call the concrete class that is created by Pigeon, and I call the addition method on it. And we'll be doing that together. It's really cool. This is a link to my GitHub, and this is also a link to my GitHub. And while I'll be showing us the demo, while I'll be guiding us through that here, if you want to practice, you definitely can fork it and work with it. All right. So this is Pigeon, and this is a standard Flutter app, which is already running, and I have both platforms running the addition method. That's correct. 30. Nothing is breaking, right? 90. So this, our current implementation is not using Pigeon. It's currently using the method channels, which we'll be refactoring from. As you can see, we're refactoring this now. And how do we do so? Firstly, we add Pigeon to our dev dependencies. I've added Pigeon because I'm trying to save time here. And once we add Pigeon, we create a Pigeon, and the Pigeon is serving as an interface to tell the code generation tool what to generate. That is what Pigeon is doing. So remember, we are trying to refactor our add method firstly, and we have our double add method. It is in an abstract class, which is an interface. You have functions without implementations. So we have a configure Pigeon here. What is it for? This is an annotation. You define an abstract class too, and just tells Flutter what to return. I'm going to switch to the finished project. I'm going to switch to the finished branch and just run the app. Undocked files. All right, let's switch. Okay. So this is the finished project, and I created some helper methods. The start time, I have a timer running. I have a timer running on the native end that returns an integer to the Flutter end. and it returns every 2 seconds. So the start timer is to tell the timer to start, the stop timer is to stop the timer, because we have to think about our memory footprint, right? And on the Flutter end, we receive the results from onReceive timer result. When I play this, you can see the results from the host platform. This is a timer running on the host platform, as we can see here. This is the time.